On today, on Histories That Matters, we have the history of Madame Foster recipe. Stay with us if you want to see it. As always, this is the flowchart. This is how the problem goes. Enjoy! So, to expand binomials, we can use the Pascal triangle, which are these numbers. These numbers represent the coefficient of the binomial of the expansion. So, if we have in row 0, we have to the 0 power, so it will be 1. But in this row 1, it will have one coefficient for A and one coefficient for B and C, and you can see that it is for all the rows. In order to know how many terms there will be in this expansion, we are going to see this. In this expansion, n is equal to 0. In this one, n is equal to 1, and so on. So this one is n equal to 5. And the term in this one, it is 1, so it is n plus 1. So in this expansion, it will be n plus 1 terms.
Oh, really? Your grandmother is the daughter of Isaac Newton? Wow, incredible.
Yeah, he was a very smart person.
Yes, she made a relation between food and math.
Newton said that a binomial with two different terms, in this case a plus b to the n power is equal to the sum of n and k, where k is equal to 0, and n combinatory k times a to the n minus k and b to the k.
So, the only thing that we have to do is substitute this value from here. So, let's go to work. So the only thing that we have to know is that this is equal to x factorial over 3 factorial times 6 minus 3 factorial. Only solve, and because x has a coefficient, we have to multiply 2 times this. The ingredients are have you seen in the kitchen of your grandma, she has had some ingredients. And each ingredient has this bread. So these represent the monograms that you have to put.
So we have this, and the only thing we have to do is to solve it. So it would be x to the 5 plus 10 x to the 9 half times y plus 45 x squared times x to the 4 times y to the square. So the ingredients or terms we need to make the dish are these.
So after solve the last situation, now you can solve this. Come on, try it.
Okay. Then it will be combinatory 20 from. Then it will be a to the 6. Oh my god. Times b to the 6.
So a simple idea. It's a little bit tricky, but now you know how to determine the ingredients. So whatever you want. Yeah, please.
Well, for cooking this recipe, I'll need 64 eggs to the 6th power, 192 x5y2. I'll need also 240 x to the 4th y4. I'll need 160 x to the 3 y6. I also need 60 x squared y to the 8, 12x y to the 16th power, and y to the 12th. And I mix everything. This is what we have.
Well, Newton's binomial has a lot of applications. Two of the most famous are it is used to obtain multiple angle identities, and also it is used for get series of the number e.
Whoa, it's not over yet! So, the last problem, we are going to find how many rotations you need to give to one dish by finding the independent term of this equation. So, we know that any combination is made like this. So, we substitute what we know. Equal x to the half to the m minus k. We have then x to the minus 1/4 to the k. And so far we know we want to this to be x to the 0, that is equal to 1. So we know that x equal to 0 equal to x 1/2 So we know that we are going to rotate the dish 84 times. Thanks for watching.